Hello, this is Professor Scott Norman at the Pittsburgh State University Automotive Technology Department. And today we are in the Automotive Fuels Lab and we are doing a Reid Vapor Pressor testing. So this morning on November 9th, I went to the local gas station and I got some samples of fuel. So I got a gallon of 87 octane, 89 octane, and 91 octane. And so the first thing I do when I get a new sample of fuel for students to test is I put it on ice because I want to save the vapors. And you know, my professor who taught me about fuels, Professor Ken Gordon, used to always say, protect those vapors. And so, so the key is that the automotive fuel, when it gets hot, will start to vaporize, and so you'll lose the light in of the fuel, which is again the best part of the fuel. And so if you don't protect your vapors and you don't have a sealed cap on your container, it will evaporate on a hot day, and then you start having problems maybe December when you have to start your snowblower or something like that, and it doesn't start because the fuel is stale, we'll call it. And so, so the first thing that I'll do with this test is I got a couple of different things. And number one, I got my fuel that is on ice, and I have my Reid Vapor Pressor tester. And so what I have is I have a sample where I put my fuel is going to be in these containers here in this apparatus, and it's chilled right now. You know, I got a bucket of ice here, 32 degrees, and so I do that so when I open up my gas can, I'm not losing any of the light-ins that I'm trying to measure. The next thing I need for this particular test, the Reid Vapor Pressor test, is I need some type of apparatus in order to measure the pressure at 100 degrees Fahrenheit. And so if you take a look behind me, what I have right here is I have my Reid Vapor Pressor tester. So I have a big 50-gallon tank that has 3 different gauges on it that I can take 3 different samples of, in which this is a bath, and it has, again, water that's warm water. It's about 100 degrees right now. And I got my 3 gauges, and so I'm going to put some fuel in my sample chambers. I'm going to then put my sample chambers into my gauge setup, and then I'm going to sink it in the back at 100 degrees, and I'm going to see how much pressure builds. Okay, and we want somewhere between 6 psi to about 13.5 psi, somewhere in that range. Since we're in November, I'm hoping that the pressure is a little bit higher. You know, it's more towards the 13 psi range because we're getting into the cold winter months, and we need that volatility of the fuel to be able to help us start our cars on cold weather. So the first step in this particular procedure is I need to take a sample, and I'm going to start off with 87 octane. I marked my containers, and so something else I did too is that when I get a sample of fuel, I take a 1 pound canister, or I take a mason jar, and I'll put 1 pound of fuel in, and I'll put the date on it, and I'll put it in a shelf, and that way I could test the fuel 3 months from now, 6 months from now, a year from now, and see how much of the light-ins have disappeared from that fuel. So these are for future testing. Again, I'm taking my baseline. I like to try to get my Reid Vapor Pressor the day that I get the fuel, because that's going to be the best. Every time I open this up, a little bit of vapors leak out. I can hear it coming out. Even though this is chilled, I can hear just a little bit of vapors coming out every time. So we're going to take a little sample. So I'm first going to put about 250 milliliters of fuel in a container. And again, you want to protect your vapors. That's going to be the key of the concept today, is make sure that I have my gas can sealed well, that on a hot day, you know, you're going to see this thing kind of balloon out a little bit. On a cold day, it should contract a little bit if it was maybe in your shed or something like that. Okay, next thing I'm going to do is I got my chilled sample container right now, so it's cold. It's very, very cold. I'm going to put my fuel in here, and I'm going to fill this up to the very top. So I'm going slow. So when I'm pouring the fuel, I don't want to agitate it a whole bunch. I want to pour it slowly, because, you know, as you agitate the fuel, it's going to try to vaporize. We're going to lose those light ins where we're trying to measure. As fuel gets old, again, those light ins evaporate, they go away, And so I'm gonna go to this as far top as I can, and a little bit of bubble there. I tend to tap it to try to get the bubbles out, and as high as I can. Okay, so that sample's in there. We're gonna put this container in ice, and that way I'll do something with that later on. Okay, so the next thing with this particular sample is I'm gonna put it in my gauge, and so my gauge apparatus has been soaking at 100 degrees right now in my bath, and I think I got the right threads on that. And so this particular gauge set has an air chamber, and so this is my air chamber, which is about 4 times as much as my sample chamber. And so the hard part is getting this thing to screw on. And I got 2 different threads, so we'll see if this is the right thread or not. And I had a 1 1/3 chance to get it right. Looks like that's not the right one, so I'm going to try the next one and see if that's the right one. We'll swap them around. So I guess 1 and 3, not good odds. Does that screw on? There we go. Nice and tight. It's kind of weird because this is warm and this is cold. There we go. Okay, so right now my gauge reading is 0. So I got my gauge, I got my air chamber, which is warm, and I got my fuel chamber down at the bottom, my sample chamber, which is cold. So what I want to do is I want to take it and I want to go back and forth. Oh, it's leaking, that's not good. Oh, you can see the pressure. Yep, I got an O-ring bad on that. Well, we're going to have to go take 2 and try to fix that. Okay, this is take 2 to see if we could get some fuel to go into the test chamber. So there was an O-ring that was leaking on my sample chamber, so I just got a different one is all I did. So I got rid of the other fuel, and I started again with a fresh batch out of my chilled container. So again, I put about 250 milliliters of fuel in a beaker and slowly poured in my test chamber, getting it as full as possible without agitating it. Okay, and it's full. Very tip top. Okay. And so what's kind of neat after this test is when you take this off, you can look down inside there and see how much vapor has gone away from this, which is kind of neat. So now I'm going to get my gauge, and so we'll go back with this one here, which is a different thread, which has been warmed up to 100 degrees, so it's nice and warm. I put it on here, I screw it in. I didn't test this ahead of time, so we'll see if this one holds pressure or not. And so I got a rag here to help me tighten it. So make sure it's nice and tight. Okay, and then now that cold fuel is going to go. So right now we're reading, 0 psi, and so I take my fuel and I go to that warm chamber. Hey, it's holding pressure, look at that. So I take all that fuel, going into the warm chamber, and so what I'm going to do is I'm going to take this and I'm going to agitate it a little bit. And so right now that fuel that was at, pretty cold, let's say 40 degrees, is agitating, and it's going into this warm chamber. I feel this chamber warming up a little bit. Right now we're already at 8 psi, so we're already, so that's good. So we have lots of volatility with that fuel, meaning it's easy to vaporize. And so I'm going to take this and I'm going to put this in my tank, which is at 100 degrees still. And we can see it go up just a little bit. And we're going to sit here and we're going to wait just a little bit. And I'm going to turn off the video and I'm going to get the other ones prepared, because the gauge will go to a maximum number and it won't go any further. It may take 5 minutes, it may take 10 minutes, it just depends on the fuel itself. But I said that I was hoping to try to get somewhere around 13, because again, we are going in the winter months, and right now we're at about 11 and a half. So, so I wait a few minutes, and then I'm gonna take this thing out and I'm gonna shake it a little bit, agitate the fuel a little bit, and then put it back in. And so what this is simulating is on a hot day. Think about this, a nice summer hot day, the fuel in your tank, you're on summer vacation or something like that, you're going down the highway, you're going over bumps, the fuel is agitating as you're driving, and then obviously it's hot, you got heat from the sun, you got heat from the vehicle, you got heat from the road surface. Think about the car that is sitting in the parking lot on a hot summer day. You can get to 120, 130 degrees pretty easy inside that car, and so that fuel tank is pretty hot. And so every time, or even, this guy right here is sitting out in the hot sun in the back of a pickup truck or something like that, and you open it, and every time you open it, you're hearing those vapors escape. Well, how much of those vapors are actually escaping? So what I'm doing is I like to do a test point where I'm actually able to see what the Reid Vapor Pressor is on a brand new sample of fuel that I got today, write it down, and then do some other testing with it to see how much of those vapors I lose. Because as I lose those vapors, in the wintertime, it's definitely going to be harder to start my vehicle or the lawnmower or the chainsaw or something like that. So we're supposed to wait about 5 minutes, and I know it hasn't been 5 minutes, but I'm going to take this out because the pressure went up pretty quick, and it stopped. I saw it stop, and so I'm going to agitate it a little bit more, just go back and forth with it. And then I'm going to put it back in again and see what else it does. And so first sample of 87 octane is warming up. I'm going to then fill up this guy with 89 and then 91 octane, and just see what the comparisons is. Is there any Reid Vapor Pressor or volatility difference between those three fuels, or is it just an octane difference between those three fuels? So we'll be back in a bit. We are back with results. We had 2 good results and 1 bad result. And so for my 91 octane, what I noticed is that my gauge is that when I looked in the water here, I saw little bubbles, just one bubble, and a couple seconds later another bubble, a couple seconds another bubble. So I thought I had my test chamber, my air chamber sealed, but obviously it wasn't, so I need to get a new O-ring for that particular gauge. But these 2 other gauges worked out just perfect. And so for my 87 octane, we are at 13.6 psi. So we're on the high end of the Reid Vapor Pressor, which is good going into winter. My 87 octane, I'm confident that it's gonna start my lawnmower or my truck in cold weather, which is perfect. My 89 anti-knock index octane is at 10.5, which is still respectable. Again, it's on the high side. That's where I expect it to be at. You have to realize that octane is a different measurement as far as compared to volatility. We're measuring volatility. How easy is it for this fuel to vaporize? So what we're going to do is that I'm going to do 2 different things since I need to run another test with my 91 octane still. Is that I'm going to take my 87 octane and think of this as you got your fuel in the tank of your truck on a nice hot summer day, and or it's in a gas can, could be in a gas tank, and you open it up. It's not sealed all the way, so we're gonna I got a rag over this because I got 13 pounds of pressure, so it's gonna go psst, and I don't want to get fuel over myself. That's not good. Walking into my air conditioning class later on today smelling like gasoline, and so I'm gonna slowly open it and let all the pressure come down slowly, so you can see the gauge drop down. So I'm actually letting all the light ends escape. Every time you open up your gas can to fill up your lawnmower, that's what's happening. The light ends are escaping. And obviously small engines like lawnmowers and chainsaws or weed whackers are a lot more sensitive than my big V8 I have in my truck. Okay, so we're at 0 at this point, and so now I'm gonna close it back up again and put it back in my bath and see what happens next. Okay, so we'll shake it up a couple times while it's out. and see how much vapors I've actually lost. Well, that's heating back up again. Again, my tank is still at 100 degrees. As I'm gonna release the pressure out of this one, and I'm gonna chill my test chamber again. I'm gonna heat up my air chamber again, and I'm gonna then try the 91 octane and see if my 91 octane is anywhere high, or is it maybe a little bit lower than 10.5 what we saw for the 89 octane. So we'll be back in a bit. We're back, and if you take a look at the gauge readings, the 87 octane that started out originally at 13.6 Reid vapor pressure, I opened up the canister that the vapors escaped, screwed it back in, heated it back up, put it in the test bath, shook it up a few times, so it's been in there for 10-15 minutes. It stopped climbing for a while. It's been sitting here for a while. It hasn't moved. We're at about 5.5 Reid vapor pressure. So that was just opening up that container one time, and the vapors escaped, and once those vapors escaped, they don't come back. And so now if I took this fuel sample and try to start a lawnmower on a cold day, or your chainsaw, or could be your pickup truck or your car, it could be a problem. The 91 octane has been in the bath for a while now, and again, I've shaken it a couple times. We'll shake it one more time. Right now we're at about almost 8.5 psi, so we're kind of mid-range, as far as that higher octane fuel, does tend to have a harder time starting cold if you don't have a high compression engine, because it has to get a lot warmer in order for it to ignite. And so high octane fuel with a low Reid vapor pressure would be really hard to start on an engine that doesn't require high octane fuel. It doesn't have a high compression ratio, so that would be a real hard thing to start cold. So we're pretty steady at about 8.5 on that 89 octane, so I think I'm going to call it that. What I'm going to do is I'm going to then take this guy here, which is our 87 octane, got to keep them straight, and I'm going to open it up one more time. So maybe I put fuel in my chainsaw. Now I'm going to put fuel in my weed eater. So I'm going to open up the test container one more time on a hot day. So you're working on the hot sun. Maybe you're one of those guys that is mowing grass all day long, and I see their fuel containers on the back of their trailers all the time. And they probably open those things probably, I don't know, a few times during the day. You're probably saying, but Professor Norman, we're not cutting grass in January. Well, maybe not in Kansas, but maybe someplace else you are. Okay, so we let all the pressure out. I figure out righty-tighty, lefty-loosey on this thing. We'll be okay. Get it tight again, and we're going to let it. So right now we're at 0 psi. We're going to put it in the bath one more time and just see if all my vapors, what does it go to now? And already it's up at 2 psi, but I'm telling you, 2 psi on a cold day would be considered bad fuel. We'll warm it back up again and give it a chance. So we'll come back one more time and take a look at the end results of this. I wanted to show you what the bath looks like inside the container. So we got a big container full of water. The water is probably pretty dirty, it needs to be changed. And I got my gauge readings. So, the almost 9 psi, 8.7, 8.8 psi is that 91 octane. The gauge reading, that's almost 3 psi. That's my 87 octane that I opened up twice, allow all the vapors to escape, and showing you that the volatility of the fuel went down quite a lot as far as your Reid vapor pressure test. Would indicate maybe bad fuel, old fuel, stale fuel. I have a thermometer sitting over here, and if I can focus on that thermometer, we're just barely above 100 degrees. So maybe 101, but it kind of regulates it a little bit, so it's pretty good to keep it right around 100 degrees is the bath temperature, so it feels warm when you put your fingers in it. And this apparatus could sample 3 different samples at the same time, if they're all working. We're back, and so the end result would be on my 91 octane is we're probably at about 8.7, 8.8 psi. So the Reid Vapor Pressor of the 91 octane was the lowest that we had. The 89 octane, which remembering was 10.5 at the end result, and the 87 octane was 13.6. Out of those three samples, the 87 octane would be the best fuel for your lawnmower, to try to, as far as cold drivability, try to get that thing to have a volatile mix in order to where the fuel is a vapor and it's able to ignite. On an automobile, a car, you got 4 cylinders, 6 cylinders, 8 cylinders. As you crank that thing over and the spark plug is firing, that spark plug is going to warm up that cylinder enough to probably get all of these fuels to actually ignite in a vapor state. But you know, the problem is that you see that on this one right here, where I opened up the canister twice already. Right now we are at about a little bit over 3 psi, which would be considered under, you know, that it's too low a pressure. And so the more of the story, and again I tell my students all the time, is to protect your vapors. You want a gas can to be sealed. You want it to be sealed well. You know, if it doesn't balloon out a little bit when it gets hot, and if it doesn't constrict on a cold morning and cave in, it's not sealed right. And of course, if it's not sealed, you're losing your vapors. And so may not be a big deal in the summertime when you have, you know, maybe a tractor that has multiple cylinders, but if you have that single cylinder lawnmower, that one spark plug takes a long time for it to finally, as you're pulling it with your hand and your arm gives out, trying to get it warm enough to ignite. As far as the poor volatility. So again, and this was only opening it twice. So I opened it 3 times, 4 times, 5 times. Obviously, we're going to see the volatility go down every single time. I can open this up now, and you know, and next time I do this, I should probably you know, measure exactly how much fuel I put in milliliters, and then I can see how much fuel I have left in milliliters. But I can take a look down inside there, and it's quite dramatic as far as the top of the fuel is you know, I would expect it to be somewhere in the threads. It was way up here at the very top. Now the top of the fuel, as far as I see, is way down at this level right here. And so my next experiment with my students would be to fill this up, measure exactly how much this holds, and then that way I'll be able to then empty this out and see how much fuel is lost, and figure out the percentage of fuel that's being lost through vapors every time you open up the container. I now have my baseline for my Reid Vapor Pressors that now, you know, I took samples of fuels. I could then take this and do a little bit more further experiments on it. I don't particularly trust my gas can cap as far as it being perfectly sealed, and I may lose just a little bit of vapor on this too. So I'm going to test that also in the future to see where we're at with that. Bottom line is protecting your vapors of your fuel. Keep it stored in a cool place, a dry place, out of the direct sunlight. I don't like to keep it, you know, in the basement or inside the house. You know, fuel is a very volatile hydrocarbon. Keep it outside in a shed, but the cooler the better. Definitely out of the sun. There's no doubt about it. I was curious what our evaporative losses were on that 87 octane, and so this particular sample chamber holds approximately 128 milliliters of fuel. Well, after we opened up this container twice and I poured the fuel back out, I'm at 112 milliliters. So when you calculate that out, that's around a 13% loss of fuel from your evaporative emissions. I remember my dad, you know, he keeps all of his fuel out at the farm, out in the middle of the sun, kind of by the tractor, you know, right there, easy to fill up all of his implements and stuff. And he kept thinking that someone was stealing his fuel, because, you know, he'd take a 5-gallon tank and maybe get a gallon out of it, and all of a sudden there's not much left. And well, it was out in the hot sun, and the cap wasn't sealed very good, and there was a hole in it where he had a pencil sticking in to try to plug up the vent, and well, he was losing his fuel a lot from evaporative emissions. And so just from this sample at 100 degrees outside, you open this thing up twice, you could be at a 13% loss as far as fuel volatility or loss of the fuel as far as volume. This is Professor Scott Norman, and hopefully you guys are liking the automotive education videos that I'm producing. If you're looking for more, you can look for my Professor Pentane YouTube channel, and I'm also, I have a website, just look for professorpentane.com. Thank you very much for watching. You guys enjoy the day.